We humans live in a strange paradox: the majority of reality is hidden from us. Astronomers estimate that about 95% of the universe is made up of mysterious dark matter and dark energy, invisible to the naked eye and detectable only through advanced science. But the unseen isn't just out there in space, it's all around us. Our senses are tuned to a very small slice of reality, a narrow spectrum of light, a limited range of sounds. Beyond those limits exist ultraviolet rays, radio waves, infrasound, and countless other signals shaping the world in ways we rarely notice. From deep-ocean animal calls to ghost-like particles streaming through our bodies, modern tools are only beginning to reveal the hidden layers of existence. It makes you wonder how much of reality is still waiting to be uncovered? Ghost particles caught at last. After more than 50 years of searching, scientists have finally detected one of the universe's most elusive particles, neutrinos, right inside a nuclear reactor, using a detector small enough to fit in a lunchbox. The breakthrough comes from the CONUS Plus experiment at Switzerland's Liebstadt nuclear power plant, run by the Max Planck Institute for Nuclear Physics. For the first time, the team observed the rare phenomenon called coherent elastic neutrino nucleus scattering, CENS, in a reactor environment. Here's how it works. Instead of bouncing off individual protons or neutrons, neutrinos interact with the whole atomic nucleus, causing a tiny recoil. Imagine a ping-pong ball gently nudging a parked car. Using ultra-sensitive germanium detectors just 20.7 meters from the reactor core, researchers recorded 395 plus or minus 106 neutrino interactions over 119 days, perfectly matching predictions from theory. This achievement, first predicted back in 1974, opens exciting possibilities for portable neutrino detectors that could monitor nuclear reactors' energy output and fuel status in real time. It also provides a powerful new window into physics beyond the standard model, potentially uncovering new particles or forces. With upgrades already underway, the CONUS Plus team expects even more precise measurements soon, promising to push the frontiers of neutrino science further than ever before. Imagine a world where the possibility of living in a simulation is not just science fiction but a 50-50 chance. That's the bold claim from a study by Columbia University astronomer David Kipping. Using Bayesian analysis, Kipping calculated a 50.2% chance that we're living in base reality, the real world, and a 49.8% chance that we are, in fact, part of a sophisticated simulation. The results show just how razor-thin the line is between reality and illusion. The idea, known as the simulation hypothesis, was first proposed in 2003 by philosopher Nick Bostrom. He argued that if a civilization can create simulations of conscious life, it's more likely that most conscious beings would be simulated rather than real. Kipping's model suggests that while simulations can only recur so far before losing detail, the odds are still split, making it almost equally likely we're at the top of the stack or inside a simulation. As quantum computing advances, future experiments may test the very fabric of our universe, potentially uncovering computational anomalies or digital glitches that reveal the truth. Until then, we remain in a state of uncertainty, living half in the real world, half in the machine. Astronomers have just uncovered a cosmic giant, a massive, interconnected web of galaxies called Kipu, stretching a jaw-dropping 1.3 billion light-years across. That's not a typo. Billion. With a B. Named after the ancient Incan quipu, a system of knotted quartz used for record-keeping, this newly discovered superstructure resembles a tangled network of galactic filaments, with thick threads branching off into smaller strands. But instead of knots, these threads hold hundreds of galaxy clusters, each containing trillions of stars. How massive is it? Try wrapping your head around this. Kipu contains 200 quadrillion times the mass of our Sun. It's so enormous that its gravity can bend the cosmic microwave background, the faint afterglow of the Big Bang, and even mess with our measurements of how fast the universe is expanding, the Hubble constant. Why it matters. This structure, along with 4 other newly found superstructures, contains nearly half of all galaxy clusters in the region and a quarter of all its matter. That's like finding out your entire city was just a tiny corner of a massive hidden continent. But Qipu isn't eternal. Over billions of years, these giant webs will fragment and collapse into smaller structures, the bones of future galaxies. Other cosmic behemoths include the Shapley supercluster 650 million light-years away, packed with galaxies. Hercules Corona Borealis Great Wall, possibly 10 billion light-years across, though still debated. This discovery isn't just about scale, it's reshaping how we understand the universe, gravity, dark matter, and cosmic evolution.